Hello everyone, welcome back. So congratulations to those who have made it this far. Before we proceed to our next module, that is module number 4, I love to have a little chat with my audience in the comment section below. So please tell us how has your experience been with the previous videos that we produced on this lab. And also you can also share from which country are you following our videos from. And after that, we will just proceed straight away to configuring module number 4, which we said in module number 4 we will be configuring MPLS VPN. Like from the practical suggested that enterprise branch users need to access the data center through the MPLS VPN. So let's see that that part was on the introduction part. The private cloud of enterprise is deployed in the equipment room of the headquarter data center. Various services of the system of the enterprise are deployed on its private cloud, and the web server on which enterprise system resides is deployed in the HQ data center. Branches of the enterprise need to access web server in the HQ data center through MPLS VPN. So that is the point I was talking about. So branches need to access the data center web server through MPLS VPN. So we are going to configure MPLS over there. 1. So on task 8 here is MPLS configuration. So step number 1, configure multi-protocol IBGP peer relationship between loopback 0 of PE1 and loopback 0 of P, and between loopback 0 of PE2 and loopback 0 of P. Configure P as the VPN route reflector, VRR, and PE and PE1 as the clients of P. To ensure successful transmission of route, runs the command undo policy VPN target on P. The original BGP that we configured was just for IP version 4. Now for this one, we are going to configure for VPN version 4. Now we will just get straight away into our routers. So we start with our router number 1. So on our router number 1, we are going to enter into the BGP view. We said these routers on the 1 will work on BGP 100. So BGP 100. Display this to see what is configured on that BGP. Here we've only configured IP BGP peers. So it has set up here with 2.2.2, that is the P router. So here we are going to set IBGP peer with for IP version 4. So IPv4 family, so say VPN version 4. We tell it peer. The peer is supposed to be on 2.2.2. That is P router, and we enable. After that, we also establish a peer with the router that is PE. PE2. PE2 is on loopback 3.3.3. So peer 3.3.3.3. We also enable. So the peer session does not exist. Sorry. So we quit and create that peer session. So quit and say peer. We are going to establish peer with router PE2. So peer 3.3.3.3. S number here is on S number 100. Then set peer 3.3.3.3. We connect to the loopback interface. So connect loopback 0. Then we go back to our VPN version 4, and we are going to enable a peer relationship for the VPN version 4. So we said peer. So here is where we are setting up the MP BGP, IBGP. So peer 3.3.3.3, you enable. See now the command has accepted. After that, we come to our P router here, which we said will act as the route reflector to reflect the routes of PE1 to PE2. So on that, we are going to enter BGP 100. After that, we tell it IP version 4, family VPN version 4. Then on that, we are going to enable P of 1.1.1.1 enable. That one is peer of PE1. Then we establish also peer for 3.3.3. So peer 3.3.3.3 we enable. That one is for PE2. So while you are on that interface, we are going to undo policy VPN target, undo policy VPN target, like the practical just said, to ensure successful transmission of routes, undo policy VPN target on P. So that's exactly what we have done. After that, we are going to configure a peer group. So peer group for establishing the route reflector. So peer group 1 enable. After we enable it, we are going now to configure the VRR, that is the VPN route reflector. So to configure the VRR now, tell it peer 1.1.1.1. The group was group 1. Also for the peer for router 2, router PE2 will be 3.3.3.3. Group here will be group 1. After that, we are now going to configure route reflector. So peer group to set a PE1 and PE2 as the route reflector clients. So now peer group 1 reflect client. And after that, we tell reflector cluster ID. Cluster ID here will give the cluster ID of 100. So now we are on PA2. We are going to establish IBGP, MP IBGP peer with the two other routers. So BGP 100. So on BGP 100, we are going to enter IP version 4, family VPN version 4, and we tell it on that router, we are going to tell it peer 2.2.2.2. We are going to enable for VPN version 4. Then also we tell it peer 1.1.1.1 enable. So you see the peer session does not exist. We quit and create that peer session. So peer 1.1.1.1 and S number here is 100. Then tell it peer 1.1.1.1 connect loopback 0. After that, we are going to now enter into the VPN version 4 and bind that to the VPN version 4. So peer 1.1.1.1 and enable command to configure the MP BGP peer relationship with router number 1, that is PE1. Save our configuration. So Control Z and save. Say yes. Also save on these other devices. So save. And also you save. So step 1 is done. We are going to step number 2. So step 2 say that enable MPLS and MPLS LDP on PE1, P and PE2. Configure the IP address of loopback 0 as the MPLS LSR ID on the 3 devices. Enable MPLS and MPLS LDP on gig 0/2 of PE1, gig 0/1 and /2 of P and gig 0/1 of PE2. So when we establish MPLS, we are going to establish them on the internal interface, the interface that connect to the P router. So like you see, this gig 2 connects to P router, and while on P, we are going to connect gig 2 and gig 1 that connect to the PE2 router. While on PE2, we are going to use gig 0/0/1 that connects to PE router. Gig 2 and these other ones are going to be used to configure route distinguishers, but while the internal one are used to configure. So on this interface, we're going to establish a VPN instance on gig 0/0/2 and gig 0/0/1 and 0/0/3. Those one are going to establish VPN instance. But for MPLS, we are going to establish them on the internal that connects to router P. So we go straight away into our router, enter the system view, and they said down now we are going to use the loopback interface as the LSR ID. So we must first of all configure the MPLS LSR ID. So we here router is 1.1.1.1. If you configure commands before you set that LSR ID, the commands won't be able to accept. So after that, we are going to enable MPLS, quit, and also enable MPLS LDP, then quit. Then they said we are supposed to enable MPLS on the interfaces that connect to one. So interface gig 0/0/2 of PE1. Then we enable MPLS, so MPLS, then also enable MPLS LDP as the practical suggests. After that, we are going to go to our P router, so quit. Then also enable MPLS on P router. So yes, so MPLS LSR ID here will be 2.2.2.2. Then enable MPLS, quit, and also enable MPLS LDP, quit. Now we are going to enter the two interfaces, that interface gig 0/0/1, enable MPLS on that interface, also enable MPLS LDP, enter interface gig 2, enable MPLS LDP. So we are done with that, you quit. Now we are on which router? We are on this router PE2. So system view. Now we tell it we enable MPLS LSR ID here will be 3.3.3.3, that is its loopback interface. So and then enable MPLS LDP. We quit, then enable MPLS LDP, then quit and enter the interface view. So interface gig 0/0/1, enable MPLS on that interface and also enable MPLS LDP. We want to save those configuration for step number 2. Say yes. Also save it here. Save. Say yes. So step number 2 is complete. Step number 2 is done. So we can display MPLS LDP session. So display MPLS LDP session. When you display MPLS LDP session, you can see here peer with the router ID 1.1 operation. It is operational, and also 3.3.3 it is operational. That is the PE1 and PE2. Their status is operational. So meaning that they are working. So let's display MPLS LDP LSP. When display MPLS LSP, you can see here the destination addresses here. Then also you can see the label. So here we have got 1080, 1024. So those meaning that what we have configured on those interfaces has been successful. Now we proceed to step number 3. So on step number 3, configure VPN instance named T to DC on PE1 and PE2. Set the RD to 100:1 and set both the export RT and import RT to 200:1. Bind gig 0/0/3.1 of PE1 to the VPN instance on PE1 and gig 0/2 of PE2 to the VPN instance on PE2. So meaning that on this step we are going to configure VPN instance, and we said VPN instance we connect them to the interfaces that connect to the externally connected devices. So the interface that connect to the PE to the CE, so provide a router to the customer edge router. So that interface that connect to the customer edge router, that is where we are going to configure the VPN instances and also import the routes into the VPN instance. So that is what we are going to do. So say IP VPN instance here, they said T0DC, not 02DC. So after that, we are going to give it IP version family Then we are told to set root distinguisher to 100:1. Then VPN target, they said VPN target here will be 200:1. Then they said we should set it on both the interfaces, so we'll apply both. When you question, you can see here, you can configure both. You can configure export community, also import community. So, but here we are going to use both because both are using the same VPN target number. So you see here the VPN assignment has become successful. After we configure that, we are going to bind the VPN instance to the interface. That is the interface that connect to the customer edge router. So you quit and you quit again. So enter interface gig 0/0/3.1. That is the interface that connect to firewalls. So first of all, you're going to display to see the IP addresses that has been configured on that interfaces. So display this to see its IP address and copy it. So let's copy this IP address, because we will need to configure it after we bind the interface to the VPN instance. When we bind the interface to the VPN instance, it automatically deletes every configuration on that interface that is IP based. So we are going to copy that and enter into that interface. So tell it IP binding VPN instance. Here we said TBC. So like you see here, all IP version 4 and IP version 6 related configuration will be removed on that interface. So VPN instance remove IP addresses for version 4 and version 6. So after that is when we configure IP address. So we just paste Control V, then display again, display this. So meaning that we've bound the VPN instance to that interface and assigned the IP address again. So we quit and also go to binding IP VPN instance to router number 2. That is, we are on router number 2 here. We are going to create VPN instance and bind the interface that connect to firewall 3 into that VPN instance. So IP VPN instance here, we said T0DC. After that, we are going to say root this IP version 4, IP version 4 family. Root distinguisher here we said was 100 on both the two routers, 100:1. Then VPN target here was 200:1. Then we use both. VPN target has been set successfully. After we are through with that, we are going to bind the VPN instance into the IP interface. So interface quit again and bind it into the interface. So we said here we are going to bind this interface that connect file to, that is gig 0/0/2. So interface gig 0/0/2. Display this to copy its IP address. Control C. Then IP binding VPN instance here we said T0DC. So then I copy the address, display this again. So in display that, you can see the configuration that have been set on that interface and also the binding of the VPN instance. Having done that means that we are complete with the VPN configuration. So we want to see if the VPN has been set. So quit and display IP VPN instance TDC interface. So you can see here on VPN instance ID, the interface number is 1 and the interface list we have got gig 2. Step number 4 says configure two static routes in the VPN instance to DC. on PE1 with the destination network segment being 192.168.0.0. These are /16, a network segment where web server client resides. The next hop will be gig 103.1 of firewall 1 and that of firewall 2. This configuration implements load balancing for returning traffic from the web server. Import the two equal static routes to the VPN instance on PE2 through MP-BGP to direct the return traffic from the web server. So we are going to import that route from PE1 to PE2. Remember, P acts as the route reflector for P1 and PE2. So it will reflect the routes of PE1 to PE2 through MP-IBGP. So what we're going to do is just configure the static route on PE1 and import them into PE2. So quit. And here we are going to say you have to know how to configure static route for the VP to add them into the VPN instance. So IP route static VPN instance here. We said our VPN instance was T to DC. Then the network will be 192.168.2.0, not .2, .0.0 with a mask of 16. Then here our next hop they said will be gig interface for gig 103.1. So interface gig 103.1 will be 10.2.2.1 for firewall 1 and firewall 2 here 103.1 will be 10.3.2.1. Both are /30. So IP address will be 10.2.10.2.1. Then to implement equal load balancing mode, we also configure it for firewall 2. That is 10.3. Its next up will be 10.3.2.1. So meaning that we've configured IP. Then enter into the BGP. So BGP 100 IP version 4 VPN instance here. Our VPN instance we said was T to DC. Then we are going to import the direct route. So import route direct. I can import the static routes that have been configured on the firewall to join to the EPE router. So you can also import route static. Also on this PE2, it will import two equal cost routes on the VPN instance 2DC on PE2 through MP BGP to direct the return traffic from the web server. So we're going to enter BGP 100. So BGP 100 IP version 4 VPN instance. We said TDC. After that, we said we are going to import the static routes that have been configured on PE2. So import route static. Also, we can import the route ISIS. So into the VPN instance, import ISIS route number 1. Come back to router 1 here. Also, we're going to import ISIS. So import ISIS 1. Let's do some verification commands. Display IP VPN instance variables. When we display IP VPN instance variables, you can see here the instance name here, T to DC1, interface gig, this one. Then IP version 4 family. We have got the route distinguisher. We consider this one and those one, and those are the configuration that have been configured for the on the VPN instance. Also, we are going to display PGP version VPN 4 all peer. Display BGP VPN version 4 all peer. When you display BGP version 4 all peer, we see the peers that have been established. We have got it. We have established a peer with 2.2.2 and 3.3.3, and their status is established. Means that the peer has been established with those two routers. So meaning that all those configurations that we configure to establish the BGP appear with the two routers was successful. We're going to configure step number 5. We are going to establish eBGP peer relationship between firewall 3 and provider edge router number 2 to enable communication between the one and also the data center. So firewall 3, we are going to give it AS of 300, so it's going to work on AS of 300 while router 2 will act on the same AS 100. So let's see the lab. Configure eBGP peer relationship between gig 0/0/2 in the VPN instance of PE2 and this one of firewall 2. 1 or 2 of firewall 2 on the web service to route, so that routes can be exchanged between BGP peers. So that is what is required. So like when we look at here, we are going to see that firewall 2, the interface that we are going to use is gig 1/0/1 with the IP address of 20.1.3.2. BGP here will be 100. BGP 100. So we are going to establish peer with 20.1.3.2. On AS number here, we said we are going to use with the AS number 300. A directly connected interface, that's the gigabit, we don't need to connect it to any interface because it is the physical interface itself. But when we configure a peer, establish peer relationship with the loopback interface, is when we have to connect that loopback interface. So we are going to stop these other two routers that we are not working with. So let's stop them and work with the two routers where we are establishing the eBGP, that is PE1 and the firewall. Also stop this other device. So we remain with only PE2 and the firewall. So enter PE2 and let's undo the terminal so that you can see how we do that configuration. UTM. You can see how we do those configuration without being disturbed with those other previous configuration. So we set BGP 100. Display this to see the peer that we have established with the other router. So we said here we have established IBGP peer with AS 300, that is the firewall, that is peer 20.1.3.2 on AS 300. So after that, we are going to bind that peer to the VPN instance. Like they said, configure eBGP peer relationship between gig this one in the VPN instance. So we add it to the VPN instance. So we said IP version 4 VPN instance, said TBC, then peer we said 20.1.3.2. AS number here was 300. So display this. You can see that AS number has been added on that VPN instance. Then we come to our firewall and also establish a BGP peer. Say admin. Password was Huawei. Shift at 123. So on that firewall, let's enter BGP 300. So peer here, we are going to establish peer with 20.1.3.1. AS number here will be 100, autonomous system number 100. After that, let's display BGP peer, display BGP peer. That is still idle because it is when it is picking up that BGP. So interface. Okay, you see now the status has been established. So it is open confirm. From open confirm to now let's display and see. You can see here the it has established an established state with the AS number 100 and the peer is 20.1.3.1, meaning that the VPN eBGP peer configuration has become successful. So meaning that the routes on this firewall will be able to be reachable with through the BGP on this router. So let's try to see if we can reach ping 30.1.1.1. Is not able to ping because the firewall, we've not allowed that interface to allow the ping permit. So if we configure the interface of the firewall to allow ping permit, those packets should be able to pass, because now the BGP help us now to communicate with devices on a different autonomous system. So that one has been implemented, and see what has remained. So meaning that for the MPLS VPN, we've configured all the required configuration. Now we are going to GRE configuration to finally finish this module number 4. So GRE configuration, the data center tenant needs to deploy a virtual private network VPN in which two subnets are created. VM1 belongs to subnet 172.16.3.0/24, and VM2 belongs to subnet 172.6.2.0/24. To enable mutual access between the two VMs, GRE needs to be deployed between the gateway leaf1 of VM1 and the gateway leaf2 of VM2. Configure the GRE tunnel based on the parameter on this table. So leaf1, the tunnel is 0, the tunnel address is 172.1.2.1, the protocol is GRE, source address is this one. So let's just begin. So we are going to save the configurations so that we stop the firewall to enable us configure GRE on the routers. Save, say yes. I'm also save on the device. Then we are going to stop the firewall and the router so that we remain with the network where we need to configure the GRE. So after we stop those two devices, let's focus on this where we want to configure GRE. We said we want to configure GRE from leaf1 to leaf2. So start those devices. So our devices are now running. So we can come to our leaf1 here. So display CU to see what have been configured on that router. You can see the neighbor exchanging LSS, meaning that OSPF is running. Neighbor state is now full with the peer of 30.1.2.1. So on that leaf1 is where we are going to establish a GRE tunnel with leaf2. So enter to the tunnel interface, tunnel 0. The practical said we use tunnel 0/0/0. On that tunnel interface, we are going to give it IP address of 173.1.2.1, the mask of 24, and also we said the tunnel source protocol. So we're going to use the tunnel protocol here when you question. You can use tunnel protocol as GRE, IPsec, IP version 4, IP version 6, IP version 4 to IP version 6 to IP version 4, MPLS or none. So here they said we use GRE. So then we go to source address. We give it source of 12.12.12.12. Then destination will be 13.13.13.13 as the practical suggests. After that, we are going to create and configure static routes towards where the network where VM1 is. So we are going to configure static routes towards 172.16.2.0 as from the practical here, VM1 belongs to this subnet and VM2 belongs to this subnet. So we must configure static route towards that network of 172.16.2.0 with the next hop being the tunnel 0. So IP route static of 172.168.168.16. The system is hanging because of my screen recorder, the device I'm using to record. When you combine it with the devices, it goes crazy. So .2.0, that one will be the network where VM2 belongs, then a mask of 24. Here, the tunnel will be used as well as the next hop. Then also we come to, let's save, Control Z and save. Say yes. Come to our live 2 and configure interface tunnel 0/0/0. Tunnel IP address will be 173.1.2.2, mask of 24. And tunnel protocol here will be GRE. Source address here will be 13.13.13. Destination address will be 12.12.12.12. Let's quit and configure the IP route towards where VM1 is. So IP route static 172.168, not 68.16.3.0, the mask of 24. The next hop we use tunnel 0/0/0. So I think we are done with the GRE configuration. Let's see. So only that is where the GRE ends. So from this planning where we are supposed to establish GRE tunnel. So let's save. So you see our link keep going on and off, but while you are on VM2, you should now be able to ping VM1 because the static route has been established through the tunnel. So ping 172.16.3.1. Request timeout. Why? Because when it tries to send the packets are dropped because the interfaces are not stable. It keeps on going on and off. But I think what I've implemented, you got the concept, you as the requirement of the practical. So if suppose you have a very powerful PC, those ping packets should be able to go through. So now our network has become stable. Let's see if we can ping. No, it is because it's happening because of when I try to stop my screen recorder, the interface becomes stable and I'm able to ping. But now here, you see now it keeps on going off on and off again. I stopped the recorder and I pinged. You see now I pinged this interface of 172.16.3.1 and it went on successfully. But now right now if you try to ping it, you see, of course, we are now able to ping. We're now able to ping our VM1. So also on VM1, let's see if we can ping our VM2. So ping 172.16.2.1. Some packets will be lost, but some will have to go through. So meaning that that one is working successfully, so that when we have to secure our VPN, the VM1 and VM2 should be able to reach each other. So I think we are through with module number 4. That was configuring the MPLS and also configuring the GRE. So we remain with only one part, that is the WLAN configuration. That is the last module that we are going to configure in this practical. So WLAN is very interesting and very simple. So that one we will do in our next module, that is module number 5, to ensure that wireless wireless users like PC1 here can be able to access our server here, can also be able to acquire the WLAN services. So thank you for watching the video. If you are new to the channel, remember to subscribe as always to support our videos. And also, if you are having a problem, remember to share it in the comment section so that we can know how we can try to help you in the best way possible. So thank you, and let's meet in our next module. That is our last module.